Tonight, a whisper from a nearby star becomes a thunderclap for explorers. Astronomers have found a world called Gliese 12b, a planet about 40 light-years away that sits tantalizingly close to the temperatures and size we imagine when we search for Earth-like environments. It is a small, rocky world orbiting a cool red dwarf, and it was found not by a single telescope, but by a modern orchestra of space and ground observatories. TESS, Cheops, ground-based photometry, and follow-up spectroscopy. It is nearby in cosmic terms, close enough that our most powerful space telescopes, especially the James Webb Space Telescope, can begin to pry open its atmosphere. Tonight, we will walk through the discovery, the numbers, and the first urgent questions every scientist asks when a neighbor like this appears. Is it rocky? Could it hold water? Can we study its atmosphere and look for signs of habitability? Discovery and validation. How we knew a planet was there. The signal that turned into Gliese 12b began as a faint, repeating dip in starlight captured by TESS, NASA's planet hunter that watches millions of stars for transit signals, the tiny periodic dimming produced when a planet crosses in front of its star. That cadence was followed by targeted observations with other facilities and rigorous checks for false positives. Is the dip due to a background eclipsing star? Is it instrument noise? The discovery teams used Cheops, ground-based telescopes, and spectroscopic vetting to confirm that the pattern was planetary in origin, and then published a peer-reviewed validation in MNRAS. The result is a transiting world we can time, size, and target. What makes the detection special is proximity and temperate insolation. At roughly 12 parsecs, approximately 39 to 40 light-years, from Earth, Gliese 12b is one of the closest temperate transiting Earth-sized planets known, close enough to make atmosphere hunting feasible with JWST and other facilities. The star itself is a small M-dwarf spectral class, roughly M3 to M4v. Cool and dim compared with our Sun, which both helps and complicates follow-up. The planet orbits much closer than Earth orbits the Sun, but because the star is cool, the planet's equilibrium temperature sits in the temperate range. The numbers: size, orbit, temperature. Here are the anchor facts we can state with confidence from the discovery analyses. Distance: approximately 39.7 light-years, approximately 12.18 parsecs. Host star: an inert, calm red dwarf with approximately 0.24 solar masses and approximately 0.26 solar radii. Cool surface temperature near approximately 3,300 Kelvin. The star shows low activity, a very helpful trait for atmospheric studies. Orbital period: approximately 12.76 days. The planet completes an orbit in less than 2 weeks. Orbital distance: roughly 0.066 to 0.07 AU, very close by Earth standards because the star is so dim. Radius: close to Earth size, reported around 0.96 to 1.0 R Earth radii in the discovery papers. Mass: early constraints left some room. Initial upper limits allowed masses up to a few Earth masses. Subsequent analyses give best fit values near approximately 1 to 2 m, but with meaningful uncertainties. That means Gliese 12b is consistent with a rocky composition, though density estimates vary depending on which mass measurement you adopt. Be prepared for the numbers to refine as more radial velocity campaigns complete, because the planet receives roughly 1.6 times the stellar flux Earth does in some analyses its equilibrium. Temperature estimates vary with assumed reflectivity, assuming no reflective cloud cover. Albedo equals 0. The equilibrium temperature can be approximately 300 to 315 Kelvin, while with a high albedo, Venus-like or clouded world, it could be much cooler. Put plainly, Gliese 12b sits in a temperate warm regime in the neighborhood of Earth and Venus, making it a crucial comparative object for understanding why two similar-sized worlds can evolve so differently. Why nearby and transiting matter, the JWST opportunity. Distance matters. A transiting planet close to Earth is an astronomer's dream because when it crosses its star, it imprints the thin atmospheric veil, if one exists, onto starlight that reaches us. That technique, transmission spectroscopy, can reveal molecules such as water vapor, H2O, carbon dioxide, CO2, methane, CH4, and traces of aerosols or clouds. Gliese 12b's proximity and temperate irradiation place it within the reach of JWST's spectrographs, which is why major teams are already planning or proposing targeted observations. If JWST detects water vapor features or a spectroscopic slope consistent with clouds, that will be a seismic shift. If JWST sees a flat, featureless spectrum, that too speaks volumes about clouds, high mean molecular weight atmospheres, or atmospheric loss. In short, the planet is close enough that the decision between hopeful speculation and real measurement is within reach, where Gliese 12b sits in the family of worlds. Compare this world to the better-known neighbors. TRAPPIST-1 planets are cooler and closer in. LHS 1140b is another nearby temperate super-Earth, but around a different host star. Gliese 12b sits in a sweet spot, large enough to produce a measurable signal, small enough to still plausibly be rocky, and close enough that many telescopes can access it. Astronomers say the best way to learn about habitability is comparative planetology. Compare similar planets and find which parameters tip the balance toward habitable climates. Gliese 12b is a new data point that may help explain why Earth remained temperate while Venus did not. What makes Gliese 12b exceptional is the combination of proximity, tempered irradiation, and transit geometry. It is a planet that turns an abstract catalog entry into a concrete target for atmosphere studies. Whether JWST finds water vapor, thick clouds, or a barren rock, Gliese 12b will teach us how planets like our own fare around small stars. Subscribe to Discovering the Unknown. We'll bring you the JWST results, the radial velocity breakthroughs, and the day we finally look into an alien sky and see whether water dances there too.